In part 5 of Unit 2, we're going to look at balancing oxidation-reduction reactions. Redox reactions that take place in aqueous solutions can be complicated. Some are simple. We looked at some simple examples in the last video, but redox reactions that take place in either acidic or basic solution can get kind of hairy. We need to use something called the half reaction method to balance them. What we do is we divide the reaction in half, the oxidation half reaction and the reduction half reaction. Pause the video and copy down these steps. This is how we use the half reaction method for a reaction that takes place in acidic solution. Okay, let's look at this example, the reaction between the permanganate and iron 3 ions in acidic solution. The first step was we have to write separate equations for the oxidation and reduction half reactions. First we have to identify what gets oxidized and what gets reduced. So we have to look at our oxidation numbers. So if we take a look at permanganate, we know that oxygen is always -2, so this is going to be a total negative oxidation state of -8. That means that permanganate has to have an oxidation number of +7. Oxygen's -2. Iron, they told us what it is, it's a +2. Let's look at it on the product side. Iron is a +3, and the manganese ion is a +2. So to identify what happened to these things, iron became more positive. That means it lost electrons. That means it was oxidized. And manganese became more negative. It gained electrons. That means it was reduced. So we're going to be dividing this reaction up into an oxidation and reduction half reaction. We're going to start with the reduction half reaction. So we're going to look at MnO4 minus going to an Mn +2. In this half reaction, we have to make sure we balance all the elements except hydrogen and oxygen. Well, we've only got one, manganese, so that's done. Our next step is to balance oxygen using water. Well, we've got 4 oxygens on the reactant side, but none on the product side. So we're going to have to put 4 water molecules over here. Our next step is to balance hydrogen using the hydrogen ion. We've got 8 hydrogens now on the product side, so we're going to put 8 H pluses on the reactant side. Now our last step is to balance the charge on each side of the reaction arrow. On the product side, we've got neutral water and manganese +2, so our overall charge on the product side is just +2. Looking on the reactant side, we've got 8 hydrogen ions, so +8, and then we're going to add that to the -1 from the permanganate ion, so we end up with +7 as the overall charge on the reactant side. We need to make them equal, and we're going to do that by adding electrons, by making the reactant side more negative. So what we'll do is also add, let me cross through that here, we're going to take this +7 down to a +2 by adding 5 electrons. So the reduction half reaction is 8 hydrogen ions plus 5 electrons plus the permanganate ion yields the manganese +2 ion plus 4 water. That's the reduction half reaction. I'm going to erase this and we'll look at the oxidation half reaction. Our oxidation half reaction was iron +2 yielding iron +3. So that's the first step. We write the half reaction. Now we need to balance all the elements except hydrogen and oxygen. That's done. There's no oxygen that we need to balance out by adding water. There's no hydrogen that we have to balance out by adding the hydrogen ion, but the charge isn't right. We've got a +2 and a +3. So what we're going to have to do is add 1 electron to the product side to make it equal. So we've got a +2 on the left side and overall a +2 on the right side. Now we need to add the half reactions together So I'm going to go ahead and copy down the reduction half reaction again. We had our 8 hydrogen ions plus the MnO4 plus our 5 electrons, and that yielded the manganese plus 2 ion and 4 water. We need to add these together so that the electrons cancel out. You can see that we've got 5 electrons on the left side down here and only 1 electron on the product side in the oxidation half reaction. What we have to do is multiply this entire top reaction by 5, so we actually end up with 5 electrons, 5 irons, and 5 irons. When we do that, we'll have 5 electrons on each side of the reaction arrow, and we can cancel out those electron terms. At this point, if there are any water molecules or hydrogen ions that show up on both sides, they can be canceled out as well. We don't have any in this example. Meant to make a line underneath it there, my bad. So since we've canceled out the electrons, what we'll do now is just add these together. We've got our 8 hydrogens plus 5 iron plus 2 ions plus the permanganate ion, and that's going to yield 5 iron plus 3 ions plus the manganese plus 2 ion plus 4 water molecules. It was a lot of work, but that is our balanced redox reaction that took place in acidic solution. These are the rules for balancing redox reactions that take place in basic solution. The method is largely the same. You just balance the reaction as if it was in acidic solution with the hydrogen ion present. Our big difference, though, is that for every hydrogen ion present, we're going to be adding the same number of hydroxides to cancel that out. We're trying to combine them to make water and then cancel out any water molecules that appear on both sides of the reaction. Your question for this section: in this following reaction, identify the oxidation half reaction. So only type out the oxidation half reaction.